different types of dopamine receptors. How do they work? And all these wonderful facts will be revealed today, and the light will shine upon them. Welcome all to his Pharmacology Difficult podcast. I'm your host Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find, and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Initially, it was thoroughly researched that dopamine increases cyclic AMP levels by activating dopamine-sensitive adenylyl cyclase. Later on, the research unfolded the surprising facts that dopamine receptors unlinked to adenylyl cyclase did exist. And there was paved the way of describing so many dopamine receptors. Firstly, the classification was made into D1 and D2, criteria being the variety of pharmacological properties and the signaling pathways. Later on, there were revealed many types of dopamine receptors. In the present times, there are 5 distinguished dopamine receptors associated with G protein coupled receptor superfamily, and broadly they belong to D1 and D2 subfamilies. No, this is all quite very simple. Don't strain on your minds. Just simply listen to me. D1 and D5, they are associated with D1-like subfamily. D2, D3 and D4 are in the D2-like subfamily. Let's quickly learn the few differentiating features amongst these receptors. D1 and D2, they couple to heterotrimeric, capital G small s and capital G OLF proteins, and they stimulate the protein kinase, capital pKa. D2, D3 and D4, they couple to capital GI, capital GO and capital GZ, or we can say capital GZ. They all inhibit the adenylyl cyclase and decrease the cyclic AMP production. They can also directly modulate the potassium and the calcium channels. It has also been proved via the interactions with beta arrestins, independent signaling of G protein coupled receptors is also possible. The dimer of G protein coupled receptor and beta arrestin, it perfectly serves as a signaling complex which further activates the protein kinase mediated signaling pathways. This wonderfully and aptly describes the D2 receptor subtype mechanism. Once the D2 is activated, further chain of events occurs. The capital GSK3 beta mediated signaling increases. This significantly plays roles in drugs like antipsychotics and mood stabilizers. Drugs acting on dopamine receptors extensively, they are used therapeutically to treat variety of CNS ailments like Parkinson's disease, schizophrenia, bipolar disorder, attention deficit hyperkinetic disorder, abbreviated as capital ADHD, Huntington's disease or Huntington's chorea, Tourette syndrome, etc. Let's, for example, talk about Parkinson's disease. D2 and adenosine receptors, capital A2A, they form a heteromer, and within this heteromer, they mutually inhibit each other via the allosteric mechanism. That is quite interesting. Don't make it complex. It's very simple. If you listen to it in a proper order and manner, they are inhibiting each other via the allosteric mechanism within the heteromer they are forming together. Now this heteromer, it serves as a great receptor target in the Parkinson's disease treatment or therapy. A2A receptor antagonists, istradifylline, actually decrease the D2 or the dopamine inhibition by the A2A receptor, and this in turn increases the D2 mechanism, action, signaling, whatever you say. Now you should not be surprised if I say currently Istradifylline has been approved as an add-on drug along with L-Dopa in the treatment therapies of Parkinson's disease. Now that's an overwhelming and a novel information for today. Let's halt now. This is the perfect time to sneak peek into the next episode coming up. That would be nothing but simply discussion about the different individual dopamine receptors. Yes, the 5 types of dopamine receptors. But till then, you have to keep patient as the fruit's gonna be knowledgeable, good and sweet. For all the updates and latest episodes of my podcast, do visit www.ispharmacologydifficult.com, where you can also subscribe to a free monthly e-newsletter of mine. It contains a lot of updates about medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you're listening for the first time, do subscribe and follow whatever platform you are listening to this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.